Hello everybody. Today we will take a look at Chapter 10, Capital Market History 1. But I would say a more intuitive title for this chapter should be Risk and Return. So in this chapter, we would like to take a look at how to calculate the return on an investment, and we'll also learn how to measure geometric and arithmetic averages of returns, and also how to measure risks based on what's called the variances and standard deviations. And this is probably the most important. We would like to understand the definition of the risk-return trade-off, and that should be based off of the historical return records. So these are the sub-chapters of this chapter. And among these 6 sub-chapters, I would like you to focus on these 5 chapters. Even if there are some missing things in this lecture video, I would like you to go back to the textbook and complete your reading. So let's start with the key takeaways from this chapter. So as I said before, the risk-return trade-off, the concept itself is the most important from this chapter. So I think you probably know this because this is common sense. Number 1 key takeaway is that there is a reward for bearing risk. So if you're taking a certain amount of risk, you would, as an investor, be requiring a certain amount of reward for that in terms of monetary return. So the higher the risk, the higher the return. That is the relationship that all investors would be having in mind. And that's also just elaborated in number 2. The greater the potential reward, the greater the risk. Okay, so you'll probably ask for more return or more reward if the risk is supposedly greater. So let's try to take a look at this relationship more in detail. Why don't we start with understanding how to measure a return and what a return actually is. So there are 2 types of return. The first one is the absolute dollar amount of return, which is the sum of dividends and the capital gains. And what we mean by the capital gains is the change in market value. So let's suppose this is a 1-period model. So starting from year 0 to year 1. Then let's suppose that you purchased a certain amount of stock in time 0 or year 0 by making an initial investment of, say, piece of 0. So this is the stock price. So you just had to spend this amount in year 0. And then later on, when the period ends, at the end of the first period, you will be selling this away so that you can just collect the ending market value of that stock, which is just, let's suppose it's piece of 1. And then in addition to that, you'll be collecting dividends from the stock, which is D sub 1. So if it were your monetary schedule, your dollar amount of return would be calculated as your dividend collection plus your capital gain. And in this case, because P sub 1 was what you sold for and P sub 0 is what you purchased at, so the difference would be the change in market value, which is the same thing as capital gain. So in other words, dollar amount of return is D sub 1 plus P sub 1 minus P sub 0, which is the capital gain. Now, there is another type of return, which is the percentage return. It's very similar to the dollar amount of return, except that your dollar amount of return becomes your numerator, and that will be divided by the initial investment. So in this case, your initial investment, which is P sub 0, so that will be your denominator. And if you wanted to calculate your percentage return, then let's say it was R sub 1, percentage return is called R sub 1, then that will be dividend 1 plus capital gain. And then you just divide the whole thing by the initial investment. And then here you see something very interesting, which is P sub 0 being repeated, right? So what you can do is you can cancel these 2 and have 1. So in other words, you can have D sub 1 plus P sub 1 divided by P sub 0 and then subtract 1 in the end. And that will be equivalent to the percentage return that you are looking for. So I actually prefer the second equation to the first one because this formula is much easier and simpler to remember. So what you have as your numerator for the second one is the so time is the sum of the dollar amount of values that you will have in T sub 1. or end of the period. So the dollar amount that you will have in the end. And what you have as your denominator is the dollar amount that you'll have to pay or what you had to purchase at in the beginning. All right. So it just shows you, it just asks you to compute the total amount of dollar value for the recent period and the old period. And just take the ratio between the two and then subtract -1 in the end. So it's simpler to remember. So that's why I prefer the second formula, but either one would work. So generally speaking, when we are referring to return, in most of the cases, you will be just referring to the percentage return rather than the dollar amount of return. So from now on, when I just refer to return without saying anything, and that will be pointing at percentage return. So how would you connect this return with the concepts that we learned before? So from chapter 9, what we learned was that the dividend yield, DY, was a dividend 1 year ahead divided by the price. And then we had capital gains yield as well, which was the capital gains, P sub T plus 1 minus P sub T divided by P sub T. So that was the formula we learned before. And then by adding that together, we had the return or required rate of return, as we put it before in chapter 9, which is the same thing as percentage return what we are trying to measure in this chapter. So if you just put that all together, we would have dividend for T sub 1 and then P sub P for the next period as well, subtracted, and then we subtract P for this period and divide it by P sub T. Okay, so it looks very much like what we saw before in the earlier slide. And then once you just put the last term into 1 because they would cancel each other out, what you see is like a more generalized format of the formula that you saw in the earlier slide. So let's take a look at it together with an actual example. So let's say 1 year ago, Peyton purchased stock A for $24 per share. Okay, so that was the purchase price. And during that year, over a year term, he obtained a dividend of $1.2 per share. And today, he sold those shares for $26 a share. So what is the total dollar amount of return and also the percentage return? So here, if we just see this kind of problem, if you're confused, try to draw a timeline. And the timeline, according to the timeline at the beginning, you purchased the stock at $24. And then later, in the end, in year 1, it was sold at 26. And then during the time period, you were able to collect 1.2 as your dividend. So P sub 1 is 26. And then D sub 1 is 1.2. And then also your P sub 0 is 24. So with this information, first, the dollar amount of return would be P sub 1 plus D sub 1, okay, which is what you earned in the end. Subtract your initial purchase amount. So that would be 26 plus 1.2 minus 24. You'll have 3.2 as your dollar return. And then in terms of percentage return, it's the same thing except that you just divide P sub 0 and then subtract 1 in the end. So the total amount of cash collection divided by initial purchase price minus 1. And you will have 13.33% as your percentage return. Now that we know the basics of returns, why don't we take a look at the historical record of stock returns? So this graph here shows you how much a dollar investment made at the end of 1925 would have grown to by the end of year 2017. And you see different types of investment vehicles such as small company stocks, large stocks, long-term government yields, long-term government bonds, and maybe also the treasury bills. So these are different types of investment instruments. And if you made your investment just focusing on small stocks, your investment would have grown to $36,931. So which is just is a humongous return here. And also, if you just focused on large stocks, then large company stocks, it would be 7,346. What if you just focused on treasury bills? then it will be 20.78. So as you can see, there is a stark difference among the investment vehicles. So what do you think you can find or take away from this graph? Does it mean that you should have focused on small company stocks instead of T-bills? Does it mean that the optimal investment strategy here would be just to focus on small company stocks? Well, the answer is actually maybe correct to some degree, but it's not showing you the full picture about the investment. So if you want to understand the full picture, all the important features about investment, there are more additional things that you need to learn. And the first thing would be the average return. So let's take a look at how much on average these different investment strategies would have earned. So to understand that, how do we measure average? So the way to measure the historical average return is a very simple way. It's what everybody knows, and a more sophisticated way of calling it would be arithmetic average. So you just take all the sum of all the yearly returns and divide it by the number of years. So it's just like how you would measure averages for your grades or your GPA. But there is an additional thing that you need to understand, which is called the risk-free rate. Risk-free rate would refer to the rate of return on a riskless or risk-free investment. And in most cases, in the U.S. market, treasury bills of 1 year maturity, 1 month maturity, or 3 month maturity are regarded as risk-free assets. So in other words, by investing in that particular investment vehicle, you are not taking any risk conceptually. That would be what a riskless investment is. And also from there, if you're earning anything, that would be called the risk-free rate. So why do we need to adopt this new concept? Because we actually want to measure what's called the risk premium. So whatever return you got on top of the risk rate would be risk premium. So excess return on a risky asset or any kind of asset that you invested in on top of the risk-free rate. So any return minus risk-free rate would be a risk premium. And this would be regarded as the reward for bearing risk. Okay, so in terms of the graph that you saw before, so these are the investment vehicles that were introduced in the earlier graph. So from large stocks, you're on average, so if you just measure the average, it has already been done for you. It will be 12.1%. Small stocks, out of small stocks, you would have earned 16.5%. Long-term corporate bonds, 6.4%. Long-term government bonds, 6.80%. And U.S. Treasury bills will be 3.4%. And during the time period, inflation was 3%. So related to all these return amounts. From our earlier slide, we learned that the risk-free rate for the U.S. market is the U.S. Treasury bill return on the U.S. Treasury bill. So that will be 3.4%. So from these historical average returns, if you wanted to compute the risk premium, then you will just have to subtract this risk-free rate from all these average returns, and you will have 8.7% for large stocks risk premium. Small stocks risk premium would be 13.1%. So you can see that the risk premium is slightly lower than the raw amount of average returns. And also, of course, by definition, the risk premium on the U.S. Treasury bill or the risk-free asset should be 0% because conceptually you're not taking any risk by investing in the U.S. Treasury bill. Now, the second thing to note from the historical record is the term risk. So remember how we tried to understand the concept of risk premium in addition to the historical average return. So how do we define risk? Risk is the dispersion or the volatility of returns. So the graph here shows you the distribution of all the common stocks return over the period of 1925 to 2017. So here we can see that sometimes the return was about almost as low as negative 50%, but sometimes if the market was good, the return was about 60%. But on average, it was between 10% to 20%. So you can see a nice symmetric distribution of returns, and this distribution or dispersion itself from negative 50% to 60% with a different probability. This is called the risk, okay? And this dispersion actually takes place and will have to be factored in when we are trying to understand the whole picture, the full picture about the historical record of returns. So how do we measure this variability? With the statistical term variance. So the variance is actually referring to the variability as well. And more details about the computation method and the formula itself, it will be introduced later on. And there is another important statistic that you need to remember, which is called the standard deviation. And standard deviation would be it's connected to variance because it's the square root of variance. So you will have to have variance to be able to compute standard deviation. So why do we need to have an understanding of the average and the risk or the variance? The reason is because we're assuming that the return distribution that we just saw before, the return distribution has a symmetric format and has a bell-shaped curve, okay? Which is called the normal distribution. So we're assuming that the returns follow the normal distribution. And one key thing about the normal distribution is if we were able to compute the mean and the variance, or the average and the variance, then we will be able to have a complete understanding of this return distribution. In other words, by just being able to compute the mean and the variance, we will be able to fully understand the characteristic of the return numerically and statistically. So how do we measure the average and the variance then? So let's first start with the average, and the simplest one, which is the arithmetic average. So arithmetic average is the simple one, is what everybody knows, the sum of returns, and then you just try to divide it by the number of periods. So R sub 1 through R sub t, and then you divide it by t, the number of the whole periods. Then that will be the arithmetic average. So no controversy, no discussion here. But there is an additional type of average that you need to remember, which is geometric average. Geometric average, to understand that, you may want to link it to the return, how to compute the return, or how we understood interest rate in chapter 4. So geometric average return would be referring to the single per period return that would give us the same cumulative performance as sequence of actual returns. So let's say in all the returns over the time period were all different. 1% in year 1, 2% in year 2, 3% in year 3, and so on. So they can be different. However, we would want to find out a single period return, single per period return that would give us the same total return as what you have earned from these different returns over the time period. So what we are assuming here is that these returns are being compounded, and we want to find out the per period return that would compound to the same final value. So this would actually give you the same amount. This would give you the formula to compute the geometric average, and this will be much easily understood with an actual example to be followed in the next slide. Another thing to note here is when we are comparing arithmetic average and geometric average, arithmetic average will always give you a higher value than the geometric average. They will in some cases, arithmetic average and geometric average only if you had the same amount of returns, like R1 being the same as R2 being the same as R3. So the same uniform returns across the time periods, then you would have arithmetic average be equal to geometric average. That will be a very special case. So why don't we just do a simple exercise question together? So suppose stock A has the following prices, okay? Before the time period begins, it was 10.32. The first period, it was 15.25, then to 12.42. And then finally, when the time period ends in year 3 or time 3, it's $16. Based on these price levels, you would like to figure out the arithmetic average return. Note that we are focusing on the return here. So how much returns over the time period. That would have to be computed first, okay? So let's assume there was no dividend. So dividend will all be 0 over the time period, and you would like to compute the return for each period. Then what will need to be done is you will just plug these numbers in the right places. So between time t sub 0 to t sub 1, which would be return 1, will be 15.24 divided by 10.32 minus 1 in the end. And the return over the first time period was 4.4767. R sub 2, which is between t sub 1 to t sub 2. Then the return in the end, the price in the end was 12.42, no dividend, divided by the price 1 period before. Then it will be 15.24. You'd subtract 1 in the end, and you will have negative 0.1850. Okay, so over this time period, you earned negative 18.5% return. And then what about from time t sub 2 to t sub 3? What about the return that you made over just one period from here, from t sub 2 to t sub 3? Then the final price was 16, no dividend, and you divide it by the price 1 period before, which is 12.42. Subtract 1 in the end, and the return you would have is 28.82%. So you'll have to, this is the preliminary work that you need to do. So whenever you are asked to compute the average return or variance of return, if you're given the price information, you will first need to compute the return for each period, and then you will start from there. This is the preliminary warm-up job that you need to do. And then second step would be to compute the arithmetic average. So it's from then on, it will be very simple. You just have to add all these returns and subtract and divide it by the number of periods. Don't use 4. In terms of the return periods, you had 3. R sub 1, R sub 2, R sub 3. All right, so time, the t here would be 3. So 1 over 3, and then you multiply it by the sum of all the returns, and it tells you that the arithmetic average would be 19.33%. Okay, so if you just try to calculate the average in a simple manner, it would have been just 19.33% return. And then there is another average that you need to compute, which is geometric average return. So geometric average return, once again, we'll be trying to compute a per period return that would give us the same result as what each return, all the returns that you're seeing here have been compounded together. So to do so, we are just going to apply the formula that we learned before. So geometric average return is 1 plus R sub 1, 1 plus R sub 2, all the way to 1 plus R sub terminal period. And then whatever time period you have, you will just use that as your power, but the power will be the reciprocal of that time period, or just put that as a ratio, 1 over that time period. So this is supposed to be t, and t is 3 in this case, so you're using 3. So 1 plus 0.4767, 1 plus negative 0.1850, and then also 1 plus 0.2882. You just multiply that all together. In other words, you're compounding all the returns inside this parenthesis, inside the bracket. And then you take it to the power of 1 over the time period, which is 3. Subtract 1, and you will have 15.74% as the geometric average in returns. So this is your geometric average return, and what it means is if over the 3-year period, per period, if you were earning 15.74%, you would have had the same amount of total return as having all these different returns over the 3-year period. And now, what if you wanted to just, because you don't want to do the formula work, what if you wanted to do this with a calculator? Then you can just use what we used to do with chapter 4. So just input all these variables as we had before. So 3 is the time period, And you started off the time period with 10.32. This is how you purchased this stock at. And then you didn't sell it away over the time period because it's being compounded. Compounded means that you're never selling away this investment. And then you will be selling it at 16 at the terminal period. No payment along the way. And then why don't we just compute IY, which is the interest rate, and you would have 15.7391 as your answer. So which is basically the same answer as what you got from your formula. So this is one tip of computing geometric average return with the help of a calculator. And there is one really important thing you need to remember, which is if you had dividends along the way, this calculator tool will never work, okay? So this is only available if there was no dividend along the way. And next, let's turn to variance and standard deviation calculation. So how will we calculate the variance? So let's start from the return information here as well. In the formula here, to be able to use the formula, you have to factor in the arithmetic average. So from our earlier slide, our arithmetic average was 0.1933. So it was 0.1933. And then to compute the variance, the original formula was the difference in returns. Okay, so the difference in return, what we mean by that is, each return, you just take the difference between this observation return and the average return. So deviation from the average, deviation from the mean. Okay, so we're just going to capture that and then square them and then add them all. Then you divide it by, just keep this in mind, when you're computing the variance, you will just divide it by not t, but t minus 1. This needs additional statistics information and background knowledge, but if you don't worry about it. Just have to remember it that way. And then just use the calculation as just shown here. So all these different returns minus the average return of 0.1933. Okay, so 0.4767 minus this, negative 0.1850 minus this, 0.2882 minus this. Okay, you just take the deviation from the mean and then just square each one of them, add them all. Then finally, you multiply that by 1 over t minus 1. Okay, so t here was, once again, you had 3 returns, right? 3, so t was 3, and then subtract 1, which becomes 2. So if you just do the calculation, then you will see that the variance is 0.1162. And then to compute the standard deviation, you will start from your calculation of variance. The variance was 0.1162, meaning that your standard deviation will be just, the square root of it, which is 0.3409. So you might be wondering what the sigma stands for. Sigma usually stands for, 1 sigma would stand for standard deviation. If you square it, it will be the variance.
Now, why don't we learn how to compute the arithmetic average and standard deviation on a financial calculator? So there's a special tool that allows you to compute the arithmetic average and also the standard deviation very easily, which can be done by working with the data and stat, which is right above 7 and 8. So first, go to data by pushing second and data right above 7. And you will see that you can input, if you scroll down, you will see you can input data for X and Y. So you actually have 2 data series, but for hours, you only have 1 data series, stock A, right? So you will just input 3 stock returns for stock A, which will be input as X variable. So the first return you have is 0.4768, enter. It's entered as the first return for X. Skip Y because you don't have any additional return series. Go to second X. Your second X is 0.1850 negative, right? So 0.1850 negative. Enter. Skip Y. And then go to third X, and that will be 0.2882. Enter. Now you have entered all your data and you're ready to move on to the step part. So second step, right above 8. If you scroll down, N says how many return series you have, which is 3. And X bar indicates your arithmetic average, which is 0.1933. So it has been automatically calculated, which is consistent with the number you see in the PowerPoint slide. And the next thing is S sub X, and this indicates your standard deviation. And your standard deviation is 0.3409, which is consistent with the formula work. So you have arithmetic average and standard deviation. And there is an additional information, which is sigma sub x. And don't worry about it. This is a different type of standard deviation and you may skip it, okay? So you will just focus on S sub x as your standard deviation and X bar as your arithmetic average, and you're done. Now, let's say if you wanted to just delete all the memories from your data, then you go back to the data by second data and then second clear work. Okay, then all the data memory will be gone.
And what if you wanted to do the calculation of the exercise on Excel? So there's a way to do that. So let's say you wanted to calculate the return first, then, so the first period price divided by 1 period before price minus 1. Once again, second period end price divided by the beginning period price minus 1. Then also, last period price divided by 1 period earlier price minus 1. So you now have all the returns being calculated. Don't worry if you don't know how to use Excel. This is only for those who are more familiar with Excel. Okay, so if you wanted to compute the arithmetic average, you can just do that with one simple formula, which is average. So average, open the parenthesis, and inside the parenthesis, why don't you select all the return series that you have above? So these return series are being just selected. Close your parenthesis. Done. You have computed the arithmetic average. And now for the geometric average, so the function name would be geomean. Open your parenthesis, and this is something that you will have to be very careful about. What you will do is 1 plus, and then the return series altogether will be selected. Close your parenthesis. Minus 1, enter. And then we'll be giving you an error. So what you will need to do in the end is do not enter directly, but you will have to do a special treatment for your enter, which is Control, Shift, and Enter together. Then you will have geometric average being computed. And then also for your variance. So for your variance here, the function is very simple. It's VAR, and then you will have multiple deviations here, and you should choose point S dot S. Okay, so VAR period S. Open your parenthesis. The same return series being selected. Enter, and you will have the same variance as your formula. And now for standard deviation, of course, you can just take the standard, the square root of the variance, or another way to compute that would be STDEV. You'll have multiple deviations. The one that you need is dot S or period S. Open your parenthesis, select the return series above, and you will have the same answer as above. Now let's come back to our the graph that we saw earlier. So our original question was whether it was an optimal strategy to focus on the small company stocks. If we just focus on the average return, because small company stocks obviously provided you with the highest amount of average returns, it probably would be if you're just focusing on the average return. But as we saw before, we would have to take a look at and factor in another aspect, which is the risk as well. So let's take a look at the trade-off here. So the small company stocks, which gave you the arithmetic average mean of 16.5, its standard deviation was 31.7. And the most inferior return, which was the US Treasury bill, its arithmetic average was 3.4. But at the same time, its standard deviation was 3.1%. So if you just take a look at its distribution, you can see that the variability or the variation of return was a lot wider for small company stocks compared to the U.S. Treasury bills distribution as well. It was kind of sticking to the mean, whereas the small company stock, it was very spread out like this. So you see the stark difference between the two. So what it indicates is, its variance or risk was a lot higher for small company stocks compared to U.S. Treasury stocks, U.S. Treasury bill compared to U.S. Treasury bills. So the same thing happened for the reward. Okay, so in terms of return as the reward, higher risk was rewarded by higher return. Lower risk was rewarded by lower return. And if you just try to track it on a two-dimensional graph, so let's suppose this was return and x-axis was risk. As you can see, US T-bill, low risk, lower return. US small stocks, higher risk, higher return. So the reason that investment on small company stocks earned higher return was because the investors who invested in these stocks assumed a lot higher risk from the beginning. Whereas U.S. Treasury bills, often regarded as the risk-free asset, they didn't take any risk. That's why it was rewarded by a smaller amount of return. So this risk-return trade-off just holds here. And if you would like to, if you're expecting a higher return, if you want to obtain a higher amount of return, then there is another aspect that you need to consider, which is that you will have to take a higher amount of risk as well. So there's a chance that you will be rewarded. The distribution is so wide that there are going to be certain times that you will be losing your money, whereas there is another chance that you will go to the other extreme and make a higher return as well. So along the way, it's going to be a lot bumpier. Whereas a U.S. Treasury bill, it's just sticking to the mean. So it's the lowest amount it will get will be much higher compared to the minimum amount of return that you see in the small company stock investment journey.